Jai Jinendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 19th question of the problem solving series, which is based on arrays. The difficulty level for this question is medium, and this question has been asked in Microsoft, Amazon, and Make My Trade. So we need to find power of x to the power n. So let's look at the example. We have the value of x given as 2 and n given as 10. So we need to compute x to the power n. So what is the value of 2 to the power n? 2 to the power 10 is 1024. What is the value of 5 to the power minus 2? 5 to the power minus 2 is 5 to the power 2 is 25, and minus 2 would be 1 by 25. So 1 by 25 would be 0.4. So we need to return that. How do we solve this? What do you think? The first approach seems to be very simple. We can traverse till 0 to n and keep on multiplying x to answer. Normally we have solved finding maximum and all those things, product of a number. So we can keep on multiplying 1 into x into x into x and till it becomes 10, and we get the answer. It's very simple. Let's code it. So it could be it's not necessary that the number is an integer number. It's 2.0 or 5.0, so we have taken as a double x, and n has to be integer, and our return value will also be in a double data type. So we can take a double answer as 1.0. We can initialize, and now 5 to the power minus 2. When this n is negative, then what do? We can't traverse the loop, right? So in that case, we can take int of nn, maybe another variable. If n is less than 0, then we can make nn equal to n into minus 1, so that our nn is always a positive number. So then next what we can do, we can simply traverse this for I is equal to 0 to nn minus 1. So nn will always be a positive number, and we can have answer is equal to answer into x, and then we can return answer, right? Simple. Let's try run it. 2 and 10, n is 10. So nn this won't come because n is greater than 0. So our nn is also 10. So 0 to 9 we are traversing it. So it would become multiplied 10 times. So 1 into 2 is 2. 2 to the power 2, 4, 3. So this way it would be running 10 times. 0 to 9 is 10 times, and we'll get our answer as 1024. For the negative case, here nn will become 2, and okay, here now return answer. So in this case also it would be returning 25. So before returning, we need to check if n is less than 0, then we will return double of 1.0 by double of answer. This would be our answer. Else we will return directly answer. Right? Simple. So what is the time complexity? The time complexity is order of n. We are traversing it once. We have not taken any extra space. So space is 1. Simple. So but the difficulty level is medium, and so it should not be that simple. Like We need to optimize it further. But how do we optimize this? Can this be lesser than order of n? We have to compute the power, right? We have to traverse it. Can we optimize it further? How do we do it? Is there any better approach? Yes, we have. Yes, we have better approach. Let me code and discuss the intuition of the better approach, and then we'll code the better approach. So now, what could be better than order of n? Normally, if it is an array, we are traversing all the elements of the array. But here, we consider that all the elements are 2, 2, 2, 2, 2, and we are multiplying everything. So, can we skip those multiplication and get the better values? Like 2 to the power 5, 2 to the power 5 or 2 to the power 10 can be written as 2 to the power 5 into 2 to the power 5. And if this can be calculated directly, 32 into 32, then this would be simple, right? We can get, but this could be a bigger number, right? So we don't know. So can we optimize this 2 to the power 5 further? This 2 to the power 5 can be reduced to 2 to the power 2 into 2 to the power 2 into 2 to the, into 1, right? And the same thing will come over here again, right? So if this is if this is temp, then this will also be temp. This will be multiplied to itself again, right? So if we already have this value, we can multiply the same value again. So we have not computed it much, right? We have just computed this part, and we got this and we have multiplied it. We did not need to we calculated this again. 2 to the power 2 will be broken again to 2 to the power 1, and we have the value. So we computed 2 to the power 1, 2 to the power 2 and 2 to the power 5 broken and calculated. So in three times, instead of traversing it 10 times, actually we traverse it we calculated it 3 times plus 1 times. So it is not order of n. We calculated very fast, right? We broken this into 2 to the power 5 into 2 to the 5. So both are same. If we find 2 to the power 5, then we have the answer. We can again multiply it with itself. To get the value of 2 to the power 5, we broke it into 2 to the power 2 into 2 to the power 2 into 1. And this is same. This will be again taken from this one. And 2 to the power 2 and 2 to the power 2 is also same. 2 to the power 2 can be broken into 2 to the power 1. These are direct numbers, we will get it. But if this is a bigger number or a decimal number, we can't keep on getting it, right? We need to break it and then use it again. It's little bit of overlapping sub-problem, and if you know dynamic programming, you would have understood this. It's very simple, those who know it. So we need to break it. So we are breaking things, dividing by 2 and breaking this. Then if we do it this way, what would be our time complexity? Simple, log of n, right? Log of 8 is, base 2 is 3 times. So log of 10 base 2 would be 3 more than 3 times. So the time complexity becomes, for the optimized approach, order of log n. And space is order of 1 only, right? So how do we solve this? How do we break this, and how do we solve this? Let's code it, and once I code it, we will try run our code, and we'll verify and we'll understand the process, how we have computed it. So the intuition is clear now. So what we can do, similarly, we can have a double of answer as 1.0, and we can have int of nn, and which is equal to say 0, and if n is less than 0, then our nn becomes n into -1 to make it positive. Right, now while we have our nn, okay, nn is not 0, okay. So if nn mod 2, that means if it is divisible by 2, if it is not divisible by 2 actually, because if this value is 1, then what will happen? Let's multiply answer is equal to answer into x, right? And then reduce the value of nn minus. Okay. Else, that means if it is, this is not mod, this is not divisible by 2. If it is divisible by 2, then let's compute this part. So x will become x into x, and nn will become nn by 2. Simple. And this is done. If n is negative, then return 1.0 double of 1.0 by double of answer. Else return answer. So this is done. This is order of log n time complexity. Let's discuss this, how this solves the problem in this way. Okay. So 2 to the power n, our x is 2 and n is 10. So nn is also 10, right? Now nn is 10, that is nn is greater than 0. Okay, so if nn mod 2, 10 mod 2 is 5, 10 mod 2 is 0. That means this is not true. Nn mod 2 means the value is 1. So 10 mod 2 is not 1. So this will come over here. So what will happen here? So 2 will become 2 into 2, 4, and nn will be reduced. Okay, so in the first traversal, what will happen? X becomes 2 into 2. That means 4. And what happens to nn1? nn1 becomes 10 to the power 10 by 2. That means 5. So we can write actually 2 to the power 10 as 4 to the power 5. This is the meaning, right? This means that 2 to the power 10 is equal to 4 to the power 5. This is the first case. Second, now what happens? X becomes 4 and our nn is 5. X was 2 and nn was 10 over here. Next, nn is 5 greater than 1. What happens to 5 mod 2? 5 mod 2 is 1. So this is satisfied. So our answer becomes answer into x. Here answer was 1 only, right? So here answer was 1. Now here answer becomes answer into x. That means 1 into 4. Answer becomes 4 and nn becomes 4 and x is still 4. In the third case, we have x as 4 and nn as 4 and answer as 4, right? Since x is 4, nn is not equal to 0, so 4 mod 2 is 0. So it would come over here. So x will become 4 into 4. That means 4 square. So x will become 16. Nn will become 4 by 2, that is 2. Nn will become 2, answer is still 4. In the fourth case, what will happen? Nn is 2. 2 is greater than 2 is not equal to 0. So here x is 16 and n is 2, right? Answer is 4. So 2 mod 2 is 0. That means we don't need to, we won't go over here. It will come over here. So x will become 16 into 16, right? So 16 into 16 is 256. What will happen to nn? Nn will become 2 by 2. That means 1, right? Right. Then our answer, what will happen to answer? Answer is still 4. Now, fifth case, nn is 1, 1 mod 2 is 1. That means this will come over here. So answer will become 256 into 4. That means 4 into 256. Answer was 4. 4 into 256. That means 1024. And what will happen to NN? NN will become 1 minus 1. That is 0. So this is completed while NN is 0 now. So it will come out of this and we have our answer as 1024. So we have actually done the same thing what we have done over here, and in this way the same process will apply to any other example, and this problem optimized solution gives us the time complexity of log of n. I hope the solution is clear, intuition, dry run, everything is clear. The link to the question has been given in the description. Please try to implement it yourself and then come to my code walkthrough session.
Here is the code walkthrough of the 19th question of the problem solving series. We need to find the power of xn. So we have already discussed the log n implementation. So I've implemented this, and if n is less than 0, we need to return this 1 by x to the power n, and the variable we have to take long temp, right? Because if we take integer type temporary value, then if the n's value is the max int max, right, then the minus 1 into int max is not equal to int min, because the maximum value of int is 2 1 something ends with 8. So when we multiply it with minus 1, then again it becomes 2 1 something to the power 8, because there are 16 bytes, right? So the negative number doesn't include that minus 1. The limit is up to minus 2 1 something, then ends with 7. So the overflow will happen. That's why we have taken the long temp instead of integer data type. So this is what I wanted to highlight. So let's run this. So sometimes we do the right solution, but our solutions is not accepted, or the test case is not passed. So we have to be careful about this. You can see here the test case has passed and it has worked fine. But if I make it as int data type, then this will fail. Then this will fail here. You can see. See here, it has failed with this condition, that runtime error cannot be represented in type int. It would have run in the test case because there is no such test case, but it failed over here. So we have to make it as long data type. Now if we submit this will work fine. So yes, the solution has been accepted. Okay. So I hope the question's explanation is completely clear. We have solved it in order of log n. So the time complexity is log n, and the space complexity is 1. We have not taken any extra space. So see you all soon in the next video where I'll be explaining the 20th question of the problem solving series. Thank you. Jai Jinendra.